Hello friends, welcome to this session 5 on Terraform, loop, meta-arguments and operators. This is the topic today, meta-arguments, that is for each loop, and a utility project to get some details, some data from AWS, and part 4 is for each loop example, instance type. 3 parts. To brief you about the first part, meta argument, let me just open this file. This file is Terraform for loops, lists, maps and count meta argument. We need to have default VPC created in our US East 1 region. How can we create that? Let me open my terminal and show you the command. If you see, you can see the command here, AWS EC2 create default VPC. When you use this command, this will create a default VPC for your region. And you can even create a subnet. We'll understand the first is the count. Terraform list and map. List is a function where we can pass a string, and map also. Terraform loops, we can have for loop with list, we can have for loop with map, and for loop with map advanced. We'll see all these with examples. Then we'll also understand splat operators, legacy splat operator which is dot star dot, and generalized splat operator which is latest, and understand about Terraform generic splat expression which is star within square bracket when dealing with count, meta argument and multiple output values. We'll also understand versions. This is our first file, versions, that will talk about which Terraform version we will be using, so there's no change. The second file, the variables file which we used in the earlier session, there is a change in that file. What is the change? This is instance type. This time we are taking it from the list. So if you see here, variable instance type list, description EC2 instance type, and the type is list. This is first type of variable which is in the form of a list element. Default, these are the default value from this list. We are going to pick up any one of the value. This is how we define the list value in normal JSON list item, and default will be T3 and T3 micro and T3 small. Similarly, instance type, another example is map, variable instance type map, description, and here we will use map function. We will pass a value. If you notice, in terms of dictionary, we are giving the default value in the form of JSON list items, whereas in case of map we are giving the values in dictionary format, because curly braces represent more of dictionary. Default values in the form of dictionary, development, QA and production. The difference is here we don't have a key based search or index based values. The values are in order, 0 1 2 3 4. We can pass that index, or we can directly specify. So there is no individual identifier for any of these values, whereas in case of map we pass the value key, development T3 micro, QA T3 small, production T3 large. So we will be able to pass a development or QA or production. Then second thing, security group, there is no change to both the files in compared to previous one. Then EC2 instance, how to reference list elements here, list values, like instance type. We need to take the instance type which is defined here. It is in the form of list, and if you are using list item, let's see how do we specify the element from this list while creating the Terraform instance and want to supply the list item. So index is to be given like element number 1. So var dot instance type list. Now if you see instance type list, That's the name we have specified. Look at this instance type list. So from this variable, we want to pass the value 1. That will be the meaning, and that's the meaning here, that's the value pass. Similarly, map values, we need to pass the key. For example, whatever key we are using, we have to pass that key. For example, we are passing production. That is the difference between a list and map. If we are using list, we have to pass the index number, first element, second element, third element. And if we say count, we can specify the count, and we can specify, for example, name is count demo dollar followed by the variable name, like count.index is what we are specifying, and which value. If we are going to count the value 1, 2, 3, 4, so which value you want to specify, that can be substituted. Interpolation can be done with $sign, and within curly braces we can specify count.index. That's example of instance 2. Will be using this value. Then output, for loop with list, for loop with map, and for loop advanced one by one. For loop with list item. While displaying the list of instances, for loop with instance, and this is how we specify. This is a for loop in Terraform. For instance in AWS instance, this type, this has to be there while creating the instance, and this has to be the identifier in AWS instance. This has to be the identifier. So AWS instance identifier, and then we are supplying the value instance public DNS. So I mean, for all instances, in this instance, give me the public DNS. Similarly, this is for loop with list. If you want to use for loop with map, you can use this for loop. For instance, in AWS instance, my EC2 VM, this is how you specify the dictionary element. Look at the difference between instance public DNS, which is a list item, and instance.id, then this arrow symbol instance.public DNS. This is how we specify for loop with map. Similarly, for loop with map advanced, this is how we specify, like for C, an instance in AWS instance dot my EC2 VM, the instance public DNS of C is what we want to print. This is advanced format of map advanced. The legacy or the original or the old operator, Splat operator with latest value is how we specify legacy Splat instance public DNS. You can specify like value AWS instance dot my VCN dot and this star dot, meaning that this will print all elements, all the values of public DNS of all the elements of the list. Similarly, this is another example, output latest generalized Splat operator. If you see here, description generalized Splat expression value DNS instance, and here we are not using the dot operator, rather we are using simple index format star value, means all the values. Then execute the Terraform command. We already know init, validate, plan, and then apply. Then observation will be, verify. We can use -auto approve also while applying. 2 EC2 instances, because count is equal to 2 of resource my VCN2 will be created. Count.index will start with 0 and end with 1 for the machine, virtual machine names. Review the output in detail. That's what we are going to study. So let's start. Now here we have 0501. The first example is we are using meta-argument count for loop. Now here we have, inside this file we have Terraform manifests. Let me see what am I talking about. This is what I just now explained, the meta count. Here we have these Terraforms. I'll explain same thing. I'll show you the code now. cat-n c1 versions. We are already aware of this Terraform block. the required version, source, provider block. We know this part. There's no change. Then second part, cat-n c2 is c2 variables. Here we are talking about the variables I used. Look at carefully. AWS region is the name of my variable, and the type is string. My default value, if I don't use this variable, it will be taken as US East 1. Instance type, my instance type, the name of my variable is instance underscore type. The description and the type is string, and default value will be T3 micro if I don't supply this value. Similarly, the key pair, instance key pair is my variable, type is string, and if no variable is used, the default will be Terraform -key. The key must exist on my OCI on my AWS account. Then EC2 instance type is list, description is EC2 instance types, and the list and these are the elements in my list: T3 micro, T3 small, T3 large. The next one is the map example. This is my name of my variable, instance type map, and this is the dictionary format where I supply the key and the value. So these are the variable declared. Next is C3 cat-n c3, and if you see here, I'm using the same set of variables. This is creating security group VPC SSH. I don't need this default VPC ID because I will be using default, so I'm going to delete it because I have already created VPC. If you do not have any default VPC, you should create one, and the command I explained in the beginning. The name of the VPC, the ingress, allow port number 22. This is my security group, AWS security group for SSH connection. Look at incoming traffic rules, allow port number 22 from anywhere. Then outgoing traffic for port number 22 is also explicitly specified. So incoming and outgoing traffics are configured in this block. Then second one is the web traffic. I'm creating a security group for web traffic also, that's VPC web. Name, this is security group, name AWS security group VPC web, and name and the VPC ID, again I'm going to remove it because I have a default VPC created now. And these are the incoming and outgoing traffic, that is ingress traffic on port number 80, port number 443, and then allow the traffic from anywhere. This is the variable part. Let's see that and let me edit these files. C3 security group. I told you that I already have the default VPC. I'm deleting this line, and this also I'm deleting. Now that's fine. Now I deleted everything. Looks good to me. The next one is the C4. Let's see that C4 cat-n c4 AMI data sources, the instance images. These are the images which I will be using. Most recent, true, honors, Amazon, filter. These are the filters for my instance: GP2, EBS, HVM, x86 64-bit. This is the filter I specified more for my data sources. Let's talk about the last file in this group, C5 instance. This is my main file. If you see the default file, main file here, the name of my instance will be my EC2 VM. The image will be this AMZ Linux 2. That's the variable I created here, AMZ Linux 2. And from this you can see the honors and filters and everything is given. So I will be using this ID from this default. Instance type, first Right now it is commented out. Subnet I'm going to delete because I have default subnet also. The instance type is coming from the variable. This is for map, and we'll go one by one. First I'll take the default value, then I will take the list value, then I'll take the map value. So we'll execute the same file 3 times. Rest of the things are user data, key file name, security groups, everything. Now security group ID. VPC security group IDs are coming from the list item. You see the list items are AWS security group VPC SSH ID and AWS security group web ID. That means 2 security groups will be created and count equal to 2. That means 2 instances will be created. Let me edit this file now. In this file I am deleting the instance type, the subnet, sorry, because I'll be using default subnet, and I'm commenting this line for production. Right now I'm commenting it out, and I'm using the hard coded value, the default value, because I want to supply the default value, that is instance type, because I have created a default variable for instance underscore type also. Or I can choose a list item, or I can choose the first item in the list, or that production value from the map. So I will execute it 2 more times. First time I'll take the default value. If I don't specify anything, where dot instance underscore type will take the default value of instance type. So therefore I'm going to execute it with the default value. So Terraform init, next Terraform plan, next Terraform validate, and finally Terraform apply. Please note that I have removed the hard coded value of VPC and subnet. Why? I will be able to provision. Last demonstrations, if you watch, you will see that I have supplied a default value of my VPC. This time I'm skipping that part and I'm using variables, and done. You can see the output, what is the output list, EC2 instance, and the output map. This is list item, this is the map, and map 2. Now I'm going to destroy it, and then I'll show you with the list also and map also. Same example with the list and map. Done. Now let's look at the second example. Here now I'm commenting out the default value instance type, and I'll be using the list item. I save this now and execute straight away plan and apply. Terraform plan, Terraform apply. This time it will use list item. Perfect. Done. I'll leave the map part for you. I'm going back, and let's look at the second part. 0502. This is the second part of this meta argument for each element. Meta argument with functions toset and tomap. We already have default VPC in the default region. In this session, in this part, we will understand for each and toset and tomap function. Data source will be AWS availability zones. No change to the versions, variables, and security group file and the data source file. Only the instance file will be changed. In the instance file, that is creating each EC2 instance.terraform file, will understand for each loop. Now Availability zone data source, AWS availability zones, my availability zones, and the filter is opt-in status, opt-in not required. This is going to be the filter. Now we have this file EC2 instance resource AMI. This will be the image which will come from the data.aws.ami.amzlinux2.id. Instance type, user data, key name, security group, and this is the important part we have to pay special attention. This is the highlighted part, this one. And this is not expected to run smoothly. It is expected to throw error. Reason being, whatever shape I will be using, whatever type I will be using, that type is not available with all my zones, because for each to set data AWS availability zones, my AWS zone or my A zones dot names, this is going to be the challenging, because this will execute this instance for every zone. So what am I expecting is it should create instance in every zone. The problem is that I don't have a one particular shape or one particular type of instance in a given zone. I'm talking about particularly zone EC2 E7 zone. Let me show you the E zone. I'll talk about it. I'll show you the output itself, will tell you, and then finally the output of all the instances. So this is same, displaying all the values. This time instead of hard coding the value, we are using a for loop. That means show me the IP address of all the instances. Similarly, public DNS, instead of using the one by one value, we are using a proper loop here. Instead of value, this also we are using as loop. And let's execute the command and see how interesting and magical it is. So here I am switching to Terraform, and inside this there is no change in versions, variables, security groups, only the instance part is changed. And the difference is that we are using loop. We are creating instances in every zone. So Terraform init, and please note that it is not expected to launch instances in every zone, or the type that will be used is not available in on zones. Let's see that part. Plan, and let's apply. Yes, and see, it is going to create instances in all the zones: A, 1A, 1B, 1C, 1D, 1E, 1F. I'm sure this is that the image that will be used, the type that will be used is not available in 1E. Therefore, it should fail at 1E, but first 4 instances it should create without any problem. Let me see how many instances it is creating. You can see that the error very carefully. If you watch this error, your request instance type T3 micro is not supported in your requested availability zone, that is US East 1E. And this is what I was predicting, because this shape is not supported. You can see the type or the shape available for a given zone, and that is why it failed. But however, if you see the instances, if you refresh the page, you will see the 5 instances already created in all regions, 5 which are just now created. And the type I was talking about, the T3 type is not available in a given zone. The next part is a simple utility to get the data. Yes, destroy. 5 instances created and destroying them. Next is it is working, let it destroy the utility. This one is the utility. What we will understand, we will try to fetch the details, the data part. Current problem, we are not able to create EC2 instance in all subnet of all of our VPC which are spread across multiple availability zones in the region. We need to find a solution to say that our desired EC2 instance type, for example, this one was creating problem for us. T3 micro. We need to find solution to say the desired EC2 instance type T3 micro is supported in that availability zone or not. In the simple terms, we give me availability zone list in the particular regions where the desired EC2 instance type is supported. Why this utility? Because in Terraform we should not go try anything directly on the large code base. First, try out the requirement in small chunks and integrate them to main code base. So we are going to do that for some same thing here, and therefore we are going to modify this version file. Hard coded the regions are also not good, not recommended strategy. This is the provider block, AWS US region East, get instance type supported per availability zone in a given region. This is the command we can use, that is AWS EC2 describe instance type offerings, location type is availability zone, name is instance type, value is T3 micro, region is US East 1, output is table. So I can use this command to get the details of my available resources in this region. So let me show you this command directly on the terminal, because I have the CLI already configured, so I can execute this command. So this will give me the T3 shape in US region, in which zone is it available in the form of table. So T3 is available in US East 1D, US East 1A, 1C, 1B and 1F, and therefore you could see the 5 instances. Next is create data source and its output. Now we are printing it like a T3 micro. Give me in which region T3 micro is available, particularly region values, like for example US East 1A, is it available or not? US East 1E, is it available or not? This is a filter we are trying. Location type is availability zone. Similarly, execute Terraform command. So we will see that output format and availability. This is not creating any resources, just filtering out the details. cd Terraform, and here we are going to run that Terraform init. These are all examples, and these are simple filters based on what is available where. Let me just execute this plan, and now apply. So this is a good example. We are going to ask what are the locations. Give me the list of zone, and you see that output here is so fast. It has printed the output super fast manner. So output of V1 to list, we are looking about T3 micro availability zone, T2 availability zone 1A is available, 1B is available. If you see carefully one by one, that 1A T3 micro available. So these are the locations. If you see 1E, it is empty list. 1F, it is available. So notice that this is not available in 1E, a given shape. Similarly, T3 micro available in 1A, 1B, 1C, 1D, 1F. So availability of our final output is, these are the regions where it is available: 1A, 1B, 1C, 1D and 1F. This is the utility example. You can create any utility example like this based on this example. That's all for this session. Thank you very much for team.